So today we are actually going to start calculating population density. And this is just a little warning, but it's a lot of math. And so we're going to break it up into a couple of different formulas for you guys to make it a little bit easier when calculating for population density. So to give you a real world example, we're going to find the population density of our classroom. And when I say our classroom, I mean Miss Rowe and I's classrooms combined with our wall open. So how it looks like really one long classroom. And so Mrs. Rowe and I actually found that our length of our classrooms, so from the end of her board to the end of my board, was 55 feet and 4 inches. Well, you'll notice on our worksheet over here that our length is supposed to be in meters. And right now we have feet and we have inches. So in order to actually calculate this correctly, we need to convert our feet and our inches into meters. Before we can jump straight to meters, we first need to calculate or convert our feet and our inches into just feet. We need to make sure that we only have one unit of measurement happening. And so in order to convert into feet, the easiest thing to do is to start with our inches. And so we know that we have 4 inches, and we want to know what 4 inches would be in feet. And so in order to do this, we have to know that there are 12 inches in 1 foot. And so we need to divide our 4 inches by 12 inches to see what it would be in feet. And so when we do this, we do 4 divided by 12. Whoops, 4 divided by 12. And we get 0.3 repeating. And so to make this calculation a little bit easier, we are going to round to the nearest hundredth. And so that means that we are going to stop at our second 3 after the decimal. So 4 divided by 12, we are going to say is 0.33 feet. Now that these are both in feet, we can add the two numbers together to figure out what it would be in only feet. So the length of our room is 55 plus 0.33, and that's going to give us 55.33 feet. Now we have to convert it into meters. So there are 3.28 feet in 1 meter. And so similar to what we just did up here, we're going to take this new number, 55.33, and we're going to divide that by however many feet there are in 1 meter, which is 3.28 feet. So now I'm going to hit divided by 3.28, and I get, again, a really long decimal. So we are going to round to the nearest hundredth again, and this time you'll notice that this 8 makes this 6 round up to a 7. And so our new answer is 16.87 meters. So this is the length of mine and Mrs. Rowe's classrooms. Now, the width. So our width when we measured was 24 feet and 1.5 inches. So just like we did above, we need to turn these inches into feet so that way we can add them together. And so we're going to do 1.5 divided by our 12 inches that are in a foot, So 1.5 divided by 12. And that's going to give us 0.125. Now that this is in feet, now we can add that to our 24. So now we have 24 plus our 0.125. And that's going to give us 24.125 feet. But again, you'll notice over here, we need meters. So we're going to take our new number, 24.125, and we're going to divide that by however many feet are in 1 meter. And there are 3.28 feet in 1 meter. And so now, oops, forgot to add my 12, not my 12, my 24. And now I'm going to divide that by my 3.28. And I get 7 point and a really long decimal. Again, we are going to just round to the nearest hundredth. So this 5 makes this 5 round up to a 6. So that's going to give us 7.36 meters. So now we have our new length and our new width. So let's add that onto our worksheet. So we had 16.87 meters for our length, and we had 7.36 meters for our width. So just like we did yesterday when we were solving for area, we have to do length times width. And so we're going to take 16.87 and we're going to multiply that by our width, which is 7.36. And our area is 124.1632. So here is our area for our classroom. So that's Miss Rowe's classroom combined with my classroom. Now we need to figure out how many people are in the room. Typically, there's about 28 in my room and about 29 in Miss Rowe's room. So we're going to add those two numbers together to calculate how many people are in the room today. And when we do that, we get 57 people. So now we need to see, well, how much space would each person have? And this is an equal amount of space. So how much equal space would each person have in this room if we divvied it up evenly? So we take the area, which we know was 124.1632, and we are going to divide that by the number of people in our room. So to write that out, we're going to do 124.1632 divided by 57 people. And let's round to the nearest hundredth again. So this 8 makes this 7, round up to an 8. And so each person would get 2.18 square meters if we divvied up the room evenly. So I want you to take a minute. I want you to predict how much space would each person have if the number of people in the room doubled. Go ahead and hit pause and write down your answer, and then when you're done, go ahead and hit play so that way we can go on with our video. So when we want to calculate population density, this is a little bit different than what we just found. So up here, we were finding how much space each person would get. Down here, we are trying to figure out how many people would take up an amount of space. And so down here, the only difference is that our formula is reversed. And so when we find population density, this time we do the number of people, and we're going to divide that by our area. And so when we do that, we do 57 divided by 124.1632. And we get a really long number, well, long decimal. And so this 9 here is going to make this 5 round up. And so we're going to say that that's about 0.46. So what does that mean, 0.46? That means that that's how many people fit into just 1 meter. And so you'll notice that's not even a full person. And so that means that there's going to be like half of a person per meter in the room. So now we're going to look at the population density for prairie dogs. And so in 1985, there were 10 prairie dogs, and our area was 10 meters. And so in order to figure out how many prairie dogs per meter, we have to do the number of prairie dogs divided by our area, and that gives us our 1 meter, or our 1 prairie dog per meter. So in 1990, we had 30 prairie dogs, and our area was 10 meters still. And so now we're going to do 30 divided by 10 meters, and that gives us 3. So that means that there's 3 prairie dogs per meter, or per square meter. So that means that now, instead of getting 1 whole square meter to yourself, now you have to share it with 3 or 2 other prairie dogs. So over here now, just 5 years later, we have 130 prairie dogs. And we're going to still have the same amount of square meters because our land amount isn't changing. And so now we have 130 prairie dogs divided by our 10 meters. And so now that means that we have to share 1 square meter with 13 prairie dogs. So it's 13 prairie dogs per square meter. So I want you to do the final 2 on your own, and then go ahead and answer why would an engineer want to know about how the population changes over time.